So we do have a number of objectives. I don't think we'll actually get to most of them. I'm not going to push too hard for us to start electric fields today. We do want to continue to explain how to charge objects. You guys said we already talked about friction and conduction. We'll revisit those, but we haven't met charging things by induction yet, so we'll definitely finish that today. We might explain the operation of a couple of things that utilize electrostatic charges. We might not do that today. And then I won't even really look at the electric field objectives, so I think the odds of us doing that today are pretty small. So I do remember last time we talked about water. Because water is a polar molecule, it can rotate in response to a charge accumulation, and because it can do that, water can kind of weakly communicate some electric charges. We revisited the issue of air being a conductor or insulator also. We said, bless you, dry air is a really good insulator, but humid air is a slightly worse insulator than dry air because of those liquid molecules that can rotate around. So what we want to do next is take a look at a device that's able to kind of semi-quantitatively tell us about electric charge. Those devices are called electroscopes. I have a few examples up here, and we'll play with those, but first let's look at the drawings of them. So an electroscope is mostly made out of conductive materials. So in this version, which is called a leaf electroscope, everything that's in black is a conductor, right, made out of metal. And then these gold leaves are obviously made out of a metal also. Now mine don't actually have gold leaves, but they do have metal leaves that are pretty darn conductive, maybe not as good as gold. And then the way that the electroscope works is if I touch it with something that's charged, right, because all of this stuff that I've outlined in blue is a good conductor of electricity, we will charge the electroscope. So in this instance, we'll have delocalized valence electrons from the electroscope move up to our positively charged thing. So our entire electroscope will end up being negatively charged, right? And if each of these gold leaves are negatively charged, the gold leaves are just kind of laying there over top of this hook. If they're both negatively charged, they're going to repel each other and they're going to stick out a little bit, right? So based on that deflection, based on that those leaves repelling each other, we would have some knowledge of how much charge was introduced. And we'll look at that in just a minute. And then here we have a different style of electroscope, like this one. It's called a needle electroscope. It really works the same way. This time everything in white is a conductor. And instead of having two small leaves, we have a small stick that can rotate, right? Or a needle that can rotate. Very small mass. So if we introduce a charge to the electroscope, maybe this time we'll make it negatively. Well, I think last time we made it negative. We can do it positively charged. If the entire electroscope is positively charged, then this needle, which is free to rotate, right, the top of the needle is going to be repelled by this part of the electroscope. The bottom of the needle is also repelled by the electroscope, so that needle should rotate a little bit. All right, so let's look at my electroscopes in action, and then we can see what other questions we have about it. So let's come on both sides of the desk, and then I think I'll film, and I'll probably just have you guys operate the electroscopes. Jonathan, can you grab right up against behind, right on the counter there, there's a black stick. Can you bring that one over like this? All right, come on, guys, both sides. You really want like a front row view here. Well, I get the actual major front row view, or Rachel does. All right, so no, you can't give it up that easily, Jonathan. All right, so Jonathan is going to charge the electroscope at least for this first time. So if you rub the black stick against this wool, that should charge it up pretty good. Okay, and then touch the rod to the top of the electroscope. Okay, do it a few more times. Yeah, recharge it. It didn't seem to work that well. All right, go ahead. Okay, take it away. Take it away. I think that's the combination that worked yesterday. Let me just look over at my sticks and make sure that's the one that I thought worked. All right, we're gonna